Hello student, what's up? This is Anup Saw from Kolkata, and today I am the new topics that I am going to introduce is the potential energy of capacitor. It's a very important topics, and it is the second video on the video series of capacitor. So I will suggest you to watch the first video on this topic. So let's start. What is called the potential energy of capacitor? Actually, whenever we supply any charge to any body, any conductor, let us suppose this is a conductor and it is standing on a wooden stand. Now if I am giving a charge q, let us suppose if I am giving a charge q, what happens that its potential also rises. So if its potential rises by v, okay, now if further an infinite similar small amount of charge dq is given to it, when it is given to it, as the charge is very small, then the potential rising will also be very small. So practically the potential v will remain unchanged, constant. So in that case, if I am finding the amount of work done will be equal to, as the charge is very small, so the work done will also be very small. So I am putting dw over here. Dw means that work done is very small, so this will be equal to v dq. Okay, v will remain constant practically. So what is actually v? V is the potential. It is the potential, and the definition of v is the work done to carry a unit positive charge from one point to the point concerned. So if I am taking a charge dq, okay, so total work done will be equal to just the multiple of v with dq. So if I am to find out the total work done, I have to integrate over it. Okay, again I will tell you that in the previous video I have mentioned that c is equal to q by v. Okay, so here if I am to find out the value of v will be equal to q by c. Okay, so here in place of v I am putting the value q by c dq. Now q dq, okay, c is a constant, c is the capacitor, capacitance of the capacitor or conductor, whatever it would be. So c will remain constant because the physical factor like the shape, size, and the surrounding neighboring materials or other things remains unchanged. So c is constant over here, so c will come out of the integral. So c is coming out, so here we will get, now if I will integrate it, I will get the value q square divided by 2. So overall the expression will be q square divided by 2c, and this is the total work done w. Actually the total work done is stored in the form of energy that is called the potential energy. Okay, so total potential energy, if I am writing here up, so then up will be equal to q square divided by 2c. Okay, now again if I am taking out the value of q from here, so I will get q is equal to cv. Q is equal to cv from this expression. If I am doing cross multiplication, I will get the value q is equal to cv. Putting the value of q over here, but I will get c square v square divided by 2c, that is equal to 1 by 2 c v square. So this is also the expression for the potential energy. Now from this expression I am doing some further extension of this formula. Okay, now up is equal to q square divided by 2c from this one. Okay, up is equal to q square by 2c. Now again there is a term called surface density of charge. This surface density of charge is equal to q by a. Okay, that is charge per unit area. This is the surface density of charge. So from here, if I will take the value of q, so q will be equal to sigma a. Sigma means surface density of charge. So putting this value over here, I will get sigma square a square divided by 2c. Now again, if there is a if it is a parallel plate capacitor, if it is a, okay, if it is a parallel plate capacitor, only in that case c will be equal to epsilon 0 or epsilon naught a divided by d, where d is the separation between the plates. Okay, so if I am putting the value of c from this expression, sigma square a square 2 into epsilon 0 a divided by d. So here the a and a square, a will be present in the numerator, sigma square a, d will also go out in the numerator section, divided by 2 epsilon 0. So this is the expression of the potential energy. Now what is this AD? Actually A is the area and D is the separation between the plate. A is the area of the plate and D is the separation of the plate. What does it mean? Actually, when two plates are kept separated by a small distance d, okay, and one is given charge and other is plate is earthed, okay, so due to induction minus charge will come here, okay, and plus charge will also come here, but actually it is connected to earth and it will be the free charge, so it will just pass to the earth, so only the minus charge will remain on this side of the plate, that is the left side of this plate. Okay, so this is the area and this is the separation, so AD will be equal to the volume. Okay, so if I am taking the value of energy stored per unit volume, that is energy density, okay, that will be equal to UP divided by AD, and that will be equal to 1 by 2 sigma square A divided by epsilon 0. Again, there is a term that the electrical intensity, that is E, will be equal to sigma by epsilon naught. Okay, E is equal to sigma by epsilon naught. Okay, E is equal to sigma by epsilon naught, and as the separation between them is very very small, so sigma by epsilon naught is uniform over in between the two plates. So if from here, if I will take the value of sigma and putting over here, so I will get the value 1 by 2 epsilon 0, that is epsilon naught E square. So this is the energy density, that is the energy stored per unit volume, and this is equal to 1 by 2 epsilon naught E square. Thank you for watching this video. Thank you.